now that we've learned how to do basic adding and subtracting with polynomials by combining like terms, now we'll focus on multiplication. Now, multiplication of polynomials you should be familiar with from your foiling methods, although FOIL won't necessarily work for every type of problem that we're going to have. Now, if you look at example 3, you can see that we are working on this in a stacked method. So if you really think back to, say, your elementary school days, you've done a stacked method before. So if we had something like, 112 times, I don't know, let's say 15, you'll see here that we're going to take the 5 and we're going to multiply it times the 2 and the 1 and the 1, and so we're going to end up carrying the 1, and then we'll have 6, and then we'll have 5, and then the next part will require us to put a little 0 here or leave a little blank for a placeholder, and then we multiply the 1 times everything, and of course we combine the like terms, thus giving us the final answer. Well, basically we can also do polynomials like this. Now, if we look at example number 3, we have our polynomials in a stacked method. Now, I don't want you to be confused by this. This is just the multiplication symbol. That's not a variable of any sort, and so kind of like what we did here back in 3rd grade. So I don't want you to be confused by that. Now, what happens here is we follow the same protocol. We're going to multiply the 3 times every part in the top one, kind of like distribution, and that gives us negative 3x squared minus 6x minus 12. Then we're going to have this 0 as a placeholder, just like we did back in 3rd grade. Now this is very important because what it does is it lines up my like terms for me, which is the effect that we're trying to get. Now, then once they're stacked appropriately, you would simply combine like terms like we did in the adding and subtracting part. And so this is very similar to methods that you've used in the past. So go ahead and try sample problem number 3 and then come back and take a look at it here in a second. Okay, so if we look at sample problem number 3, we're just going to go through this process of multiplying the 1 times everything on the top, and of course 1 times anything is just simply itself, so I'm going to rewrite that. Then it's very important that I use a placeholder with a 0 there, and I will multiply the 2x times everything. So 2x times negative 5 gives me negative 10x. 2x times x gives me a positive 2x squared. And then 2x times 4x gives me a positive 8x to the 3rd. Now we can see all of our like terms are lined up or stacked on top of each other. So it's simply just combine those like terms. 8x to the 3rd plus 6x squared. And keep in mind that this is an understood 1. So that's minus 9x. And then a negative 5, and that would be our final answer. Now, that is an unusual way for you to probably multiply polynomials. Most of you are probably accustomed to seeing polynomials multiplied side by side. Now, you've been more comfortable multiplying two binomials per se, and that allows you to use the FOIL method. Now, FOIL only works for two binomials, and you have to be careful of this. But if you understand what FOIL actually is, you'll be fine. The foiling process just simply means to distribute each term. So if I distribute the x to both parts of x minus 3, and then I turn around and I would distribute the 2 to both parts, you've basically done the f and the o part here, and the I and the L part there for FOIL. Now, if you look at example number 4, FOIL doesn't work here because we have a binomial times a trinomial. But this same distributive process does work. So if I take the x and I distribute it times everything in there, which is what I'm doing with this step, Then I take the negative 3 and distribute it times everything, which is what I'm doing in this step. Then I get a whole bunch of terms scattered about that I just need to combine the like terms. And so multiplication is still just the distributive property. So go ahead and try sample problem number 4 by distributing both parts of the x plus 2 and see what you come up with. Okay, so we'll start by distributing the x. So x times 5x squared, so we get 5x to the third plus 3x squared minus 1x, and of course you don't have to write the minus 1, you can just write minus x. Then I'm going to distribute the 2, so that's going to give me 10x squared plus 6x and minus 2. And now I look for like terms, and so I don't see an x to the third anywhere else, so I write that first. And what I'm going to do here is, so that I write this in standard form, I'm going to go ahead and look for the terms that should be next in order. So I did x to the third as the highest exponent. Now I'm going to look for all my squared terms. So I've got 3x squared and 10x squared. So that's 13x squared. Then I'm looking for my x's. So I got x and x. So negative 1 and positive 6 gives me a positive 5x. And then lastly, my whole numbers. And that way I have it already written in standard form by taking it in that order. And so there's your final polynomial after multiplying. Okay, so now you've seen multiplying polynomials in a stacked method and a horizontal method as well.